Hello, my friends. Welcome to Origins. My name's Don Chapman, and it's my privilege to be your host. Origins is a forum where we take the evidence of science and use it to validate the truth of creation. And we do that by interviewing scientists. And I have a wonderful man with me today. Dr. Danny Faulkner is here. Dr. Faulkner, it's so good to have you. And today we're going to talk about comets. Now, I have to admit that this is not an area where I thought there would be a difference between an evolutionary view and a Christian or creationist view, but you see them looking at it from a different perspective.
I sure do, Don. You know, there's a big difference between the worldview between creation and evolution. There's several things, but one thing I think is really stark there is the fact that age comes into play. The Bible indicates the world was created in just a few days and maybe only a few thousand years ago as opposed to billions of years ago. And so I think that we have a big discriminator there between billions of years and just thousands of years. And I think comets can tell us quite a bit about that.
Well, I'm really anxious to hear how comets come into play to show us that there's indeed a young creation. Go ahead.
Do you remember Comet Hale-Bopp back in 1997?
I do remember that.
Well, that was one of the brightest comets ever seen, certainly brightest in my lifetime. And comets are kind of unpredictable. And they come and go, and a lot of story there, lore in the past. People thought that when comets came, kingdoms fell, pestilence, famine, all sorts of terrible things. Even the fall to King Harold at the Battle of Hastings in 1066 was blamed on comet. Came over at that particular time. I believe this is a photograph of Hale-Bopp. It was a very bright comet. You know, you could see it even from Manhattan. I'm not talking Kansas, I'm talking New York City. It was that bright. It was not really huge in the sky because we never got very close to it. But it was incredibly bright. Yes. You didn't need a dark sky to see it at all. And the comet, you have down in the center of this area down here, a little thing we call the nucleus. And I'll talk more about that later. Just a few miles across, made out of some rock and ice. And then the sun shines on it. The sun is down towards the lower left here. And the sun shines and heats up the gases. You form this thing we call the coma, and it can be thousands, tens of thousands of miles across. And then the sun's radiation blows back the debris, the dust and the gas to form two different types of tails coming off that. All that coming off a little chunk of ice.
It really just starts with a piece of ice.
A piece of ice and a little bit of dust thrown in for good measure.
Okay.
That's a very interesting, again, it just all this beauty and wonder out of such a tiny little thing in many respects. Okay, well, let's talk about what the comet is. We had a guy named Fred Whipple back around 1950, I think, or maybe a few years before that even, who suggested what we call the dirty iceberg theory, this idea that this big block of ice-like material made of frozen water, but also frozen carbon dioxide, methane, things like this, and a little bit of dust thrown in. You know, Don, in northern places where you have a lot of snow in the winter, they scoop up the snow in the parking lots and the malls and things like this. You get this big mountain, and then it slowly evaporates or melts, and it looks really dark after a while, really
like
dirty
looking. Snow.
Yeah, it's exactly what a comet nucleus looks like up close.
Right?
We've had photographs from space probes up close.
This isn't the same Whipple that squeezed the charm.
No, different Whipple.
Had to check. Okay.
Well, I always wondered about that myself. I had to check on it myself too at one time. The nucleus is small, just a few miles across. Hale-Bopp, they estimate its nucleus is maybe 25 miles across, which is the biggest ever seen.
So that's the only solid material, is about a 25-mile.
For a big one. Now, see, Halley's Comet, everyone knows how famous that comet is. That has about an 8-mile across nucleus. Very tiny, about the size of a good-sized city.
When we're talking in space, that's really small. Yeah.
It is, very tiny. And the gases and the dust get released near perihelion. Now, this word perihelion, don't get afraid of that word. That means, para means near, and helios means sun. These things go in big, long, elliptical orbits, something like this, and they come near the sun only once every orbit.
Okay.
So when it's near perihelion over here, the sun's heat heats it up and evaporates or sublimes those gases, knocks the dust loose, and that's also the gases start to fluoresce from solar radiation.
So when it's the other end of the orbit, it doesn't have a tail?
Oh yeah, over here it's called aphelion, and in fact the tail only appears close to perihelion. Most of the orbit over here,
there's no tail there.
And you can't really see the comet at all. It just disappears, it's so small.
Yeah.
You know, the activity all happens here near perihelion.
Okay.
And it's like coma forms as well. That's the thing that we really catches our brightness, and then the tails get blown back. There's what we call an ion tail or a gas tail, and that's blown back by the solar radiation, and then the solar wind pushes the little dust particles back.
Okay.
And the two different tails, very interesting development there. They have different color and different makeup, of course. Here's a little diagram just showing a little more detail. I just mentioned this in passing. Down here is this tiny little nucleus. We've made it bigger than it really is because it's just a few miles across. The sun is down here someplace, and it's blowing, its solar radiation heats up the material, blast off into this coma here, and that can be tens of thousands of miles across. And again, the ion tail gets shoved pretty much straight back away from the sun, and the dust tail kind of arcs back behind it like this. You know, it's a common misconception. People think the tail trails behind the comet as it moves, but it doesn't. In fact, as the comet comes toward the sun, the tail points away. And as it goes around the sun, it points away. So as it leaves the sun, the tail actually leads it. It doesn't trail behind the comet.
Oh, is that right?
Common misconception about that. Again, it's being driven by solar wind and solar radiation. And this illustrates what a typical comet orbit might look like. You've got the Earth's orbit down here, and it's nearly a circle. We're looking at it kind of edge on, but it really is a circle. But the comet's orbit is a big, long ellipse. Down here's perihelion, where it's closest to the sun. Here's aphelion, and it shows the tail pointing away from the sun, away from the sun. No matter which direction the comet's moving, the tail always points away from the sun. But only close to the sun would you have activity. Far out near aphelion, particularly if it's really a long orbit, the thing cools down and virtually disappears. With large telescopes today, we have the ability to follow large comets such as Halley's pretty far out. Now, we had the Deep Impact mission a few years ago. It actually went to a comet and slammed in a big piece of metal like a hammer into the comet to knock debris loose, and they had telescopes all around the world studying the debris. We've also had some other recent developments in just the past few years. We found the density is very small. It's around 5% or maybe half of that of water. Water is 1 gram per cubic centimeter. These are 0.05 to about 0.5. Now, if these things are made out of ices and dust, you expect the density to be close to that of water, which is 1.
Sure.
So the way we explain that is we think that these comets are very porous.
Okay.
Remember my example to the big piles of dirty ice and snow? Well, it's a lot fluffier than that. You're going to have to remove a lot of that material. Imagine like a bunch of holes in it like Swiss cheese.
Sort of like a sponge, maybe?
Sort of like a sponge, except even more so with the holes being really big. And that means the comets are barely held together. Barely held together. So it's real easy to make them fall apart. Just passing close to a planet can rip them apart tightly. We've seen that happen
A little bit
before.
of gravitational pull.
Yep.
Yeah.
The gravitational pull can really do a number on it there. Here's something interesting. Back in 1994, we had a comet called Shoemaker-Levy 9. And it actually came close to Jupiter, was shredded, this is in 92, shredded into several comets, about 24 of them. And in 1994, as on the way back out from the sun, each piece slammed into Jupiter. That comet's no longer around. It was totally destroyed with a collision into Jupiter.
It ran into Jupiter and destroyed itself.
Mm-hmm. Over several days. This is this big black eye you see out here. This is Jupiter. This big black eye right here is just one of the impacts.
Yeah.
And you know, if you had a small telescope, you could set it up in your backyard. I did. And you could see these little dark spots on Jupiter. In 400 years of observing Jupiter, we've never seen anything like that.
Wow.
So we now know, we have evidence directly now that comets occasionally collide with planets, and that's a catastrophic loss at that point. This is where the age indicators come in. You know, they have very short lifetimes. Could you imagine every time it comes near the sun, it's a tiny thing, it's very porous, not a lot of material there, yet it blows up, it has this huge coma with a large tail. It's really sucking off a lot of material, blowing a lot of material off of the nucleus. It can only survive a few trips around the sun, and it's completely depleted. It's gone. So these things wear out by evaporation. And we also have them colliding like they did in 1994. One other thing I haven't really mentioned much is the fact that you can have ejection from the solar system. As these comets come close to planets, they can be ejected, kicked out, and lost completely. And the whole upshot is that we can run calculations on this, and we find out that comets, if they date from the beginning of the solar system, and everybody seems to think that they do, then the solar system must be far younger than 4.5 billion years. the solar system can probably be no more than, say, 100 million years, which is far less than a billion years.
Now that's really fascinating, because one of the things I just need to ask for our viewers who aren't scientists is, could comets still be forming, or is there pretty much a consensus that all comets were formed at the beginning of...
It's a consensus, creationist, evolutionist alike, that comets date from the beginning of the solar system.
So that makes them a constant indicator to age.
Right, and so if comets have been orbiting the way they always have been, then the solar system must be very young. It cannot be billions.
Disappeared
long ago.
Billions and billions of years
billions
ago.
and billions of years ago, they should have all
say
disappeared.
Yeah, okay.
But see, if the universe is only, the solar system is only 6,000 years old, then we certainly will see comets
still have lots
today.
Of comets. That's fascinating.
It is, and you might think, well, evolutionists know about this? Well, yes, they do, and they've made some suggestions. An astronomer around 1950, a guy named Gerard Kuiper, suggested the Kuiper belt. These were for short period comets. And about the same time, a man named Jan Oort suggested what we call the Oort comet cloud. And these are two different groups of comets. We have the short period and the long period comets, and you can see that 200 years as less than 200 years as opposed to greater than 200 years, but more important than that would be the inclinations of the orbits and the directions they go. Remember, I talked about those things being elliptical orbits. They can have any inclination to the plane of the planets. The planets orbit the sun in roughly the same plane. The short period comets tend to have low inclinations, 10, 15, 20 degrees. The long period tend to have inclinations of all types, up to 90 degrees.
Okay.
And then the short periods tend to go around the sun in the same direction the planets orbit, counterclockwise, or prograde, as we show here. But long period comets, half of them are going the same direction the planets are going, and the other half are going the other direction, suggesting that there's something very different about these two types of comets. And so we have here a little sketch of what the two might look like. You've got to understand, here's the sun way down in the middle. The planets are all down in here. That's the solar system as we know it. Then there's a kind of a donut-shaped thing out here beyond the orbit of the planets. That's the Kuiper belt, hypothetically. And it would be like 40 times the distance of the sun, 40 to 60 times the distance of the sun that the Earth is.
But you can't see a Kuiper belt.
No, you can't see it.
It's simply hypothesis,
these are
right?
Hypothetical comet nuclei orbiting out there.
Okay.
And in far out here, thousands and thousands of times the distance of the sun from the Earth, you have this spherical distribution of comet nuclei we call the Oort cloud. And they generally stay there, but the idea is the planets, sometimes their gravity affects these Kuiper belt objects, pulling them in to the inner solar system, so you're replacing short period comets as they die, get ejected, destroyed. They're being continually replaced from the Kuiper belt. And ditto for the long period comets, coming down out of the Oort cloud. They come down out of the cloud because of interactions of some star nearby. Its gravity affects this and changes its orbit. So those where evolutionists would say we get
new comets.
New comets coming from the Kuiper belt
right.
core cloud. They're not really new, they've just been stored there for billions of years.
Become observable to us.
Yeah.
Okay. Well, that's fascinating. We've got to take a break right now. We're going to come back and we're going to see the implications that this has for us as creationists, so don't you go away.
Creation versus evolution. You weigh the evidence. Voyager space probe, an amazing discovery. In 1979, the Voyager space probe filmed a volcano erupting on Io, one of Jupiter's moons. This discovery amazed the NASA scientists who believe in the evolutionary concept that the solar system is billions of years old. Small bodies like this moon should have cooled off long ago. The fact that Io still has volcanic activity when it is supposedly almost 5 billion years old has no adequate explanation. Perhaps Io is still hot because it is not very old. Today's guest on Origins, Dr. Danny Faulkner, is also the author of Universe by Design, an explanation of cosmology and creation. This is an excellent book for upper-level homeschool curriculum or the library of an astronomer. Orders are being taken at 1-877-CRS-BOOK. Dr. Faulkner has a degree in math, his master's in physics, and a PhD in astronomy from Indiana University. He is full professor at the University of South Carolina, Lancaster, where he teaches physics and astronomy. For more information about our guest, you can write to Dr. Danny Faulkner, 1402 University Drive, Lancaster, South Carolina, 29720 or send them an email.
We're back with Dr. Danny Faulkner, and we're talking about comets. Dr. Faulkner, you were just saying before the break, the comets are kind of porous, they're kind of delicate, they don't seem like they would last for a long, long time. So the evolutionists have said there's a Kuiper belt for the short ones, and there's the Oort cloud for the long-term ones. Is this true? Is there evidence that they're there, the Kuiper belt and the Oort cloud? Are they really out there?
Well, that's a good question. Let's talk about the Oort cloud first. Remember, that's this hypothetical distribution of comet nuclei orbiting really far from the sun. Okay. And I got a great quote here. I could have written this quote myself, but I didn't. It says, many scientific papers are written each year about the Oort cloud, its properties, its origin, its evolution, yet there is not yet a shred of direct evidence for its existence. That was written by the late Carl Sagan, who many of your viewers will remember from 70s and 80s, very famous astronomer back then.
Sure he was.
Even though it's been a few years since he wrote that, nothing's changed. Nothing's changed in that. There is no evidence. You know, this is something that's physical, which means it could be studied with a scientific method, but I learned science being the study of the natural world using the 5 senses. So if you can't see it, can't smell it, can't taste it, can't hear it, can't touch it, it's not science. Now, given that standard, is this really science? I don't think it is. I don't think it's a scientific principle. It could be someday, perhaps. But right now,
it would have to be discovered, because right now, using traditional science, it's not there.
These nuclei are very small, and when they get far from the sun, they're very, remember how black I told you that for all the crud on them, all the dust?
Yes.
They're very far out from the sun, extremely faint, far beyond the ability for us to see with telescopes.
But there's no even indication or hint that they're there. Okay.
All they talk about here about any indirect evidence would be computer simulations of how they could work. They would even talk about the orbits of the comets, where they came from, but it doesn't tell us that actually that's where they came from. Just a plausibility argument. So I would say the Oort cloud is not a scientific principle.
What about the Kuiper belt?
Okay, Kuiper belt's a little trickier because they begin looking for objects in the Kuiper belt. Remember I said they're like 40 times the distance. I'll say 40 astronomical units. An astronomical unit is the distance between the Earth and the Sun. Okay, Neptune's at 30 astronomical units, so they think the Kuiper belt picks up maybe 40 to 60 astronomical units from the Sun. And they began looking for these back in the 1990s. Around 1994, I believe they found the first object out there other than Pluto. They don't think Pluto's a planet anymore. They think it's actually just one of the larger of these Kuiper belt objects. Now, over the years, they've found hundreds of them now. There are hundreds of them orbiting out there. And as they find these, they start saying, well, this must be the Kuiper belt we've been looking for all this time. Again, you expect to be a donut-shaped distribution of things orbiting out there, very icy. And so since they started finding these things in abundance, they started saying, well, this is a long sought-after Kuiper belt. I prefer trans-Neptunian objects, TNOs for short.
Trans-Neptunian objects.
Because it means just trans means beyond, and beyond Neptune. And these are orbiting beyond Neptune, no doubt about it.
Okay.
So these are trans-Neptunian objects. And are they Kuiper belt objects, or are they trans-Neptunian objects? Well, other astronomers disagree about all of this. I have some questions about these, if these are really Kuiper belts. First of all, most we find are more than 10 times the size of the largest comet nucleus ever seen. Hale-Bopp was 25 miles across. These things are hundreds of miles across. So they're at least 10 times larger, but a better measurement of how much production that you can get from a comet is not the diameter, it would be the surface area or even the volume. So 10 times larger translates into 100 times or 1,000 times in surface area or volume. So I have to question, if these are indeed comet nuclei, why have we never seen the mother of all comets, as it were, coming in?
Do we have a pigeonhole for that? If it's not a planet and it's not a comet, it's a what?
It's an asteroid or a minor planet.
Asteroid, okay.
And that's what I like. I call them asteroids or minor planets.
All right.
And I think that's what we're finding out here. Also, the densities are too great. And this is where they're getting a little technical things here with density, because we measure density by taking the mass, dividing it by the volume, and we can figure out what they're made out of then. Things that are rocky have high densities, like 3 grams per cubic centimeter. Icy have near 1, so it tells us a lot about what these things are made out of. And we have the density of at least one object we've now measured. We measured its size and its mass, because it has a little satellite orbiting around it. That object's called Pluto, by the way.
Okay.
We know its density is 2.0, which is consistent with a half ice, half rock composition. We know comets don't have that much rocky material. They're almost entirely what we call the more volatile materials, the icy, the gassy sorts of materials.
All right.
So the densities are all wrong. And this has a real problem, because the best I can get is a 1 1/4 density, not 2, as we know for Pluto at least. And by the way, we're pretty certain that the other large objects out there, the other TNOs, match that density pretty well because the compositions are the same. We know that from spectra of these things.
Whatever these are, they're all pretty much the same.
Yep, and satellites very far from the sun, such as Jupiter and Saturn satellites, they tend to have a 2.0 density as well, very close to that. So these are consistent with other objects out there in the far reaches of the solar system.
Okay.
We know they're not comets.
Right.
So I think we're seeing things very similar to the satellites of the larger planets out there. And so a couple of questions. They could say, well, maybe comets have a non-solar abundance. When I say solar abundance, their composition matches that of the sun pretty well. We know what the sun's made out of, we know what comets are made out of. That's a radical departure from what we've always thought about these things. And if the densities are different, it suggests that maybe there's been what we call geological reworking. You've been settling material to the middle and lighter material rising off and outgassing and so forth. But the problem is, those objects out there are no longer going to be the pristine samples of the solar nebula. The solar nebula is this thing supposedly where the solar system formed out of billions of years ago. And this has been doctrined for a very long time. In order to explain these things out there, the TNOs, to be sources of comets, are going to have to give up an awful lot in order to do that. And
So
I don't
it's
think
not consistent with their own theory.
And I don't think the data will support it either.
Okay.
So I think we're back full circle. I don't think the Kuiper Belt's been found. There's good evidence to suggest that these are just another asteroid belt very far from the sun. You know, back a few years ago, they found this thing called Sedna, and it's 60% the size of Pluto. That really is interesting. 60%. It orbits pretty far out. It goes hundreds of AUs, or astronomical units, from the sun. Then we had this thing called 2003 EL61. Just rolls off the tongue, doesn't it?
That's a beautiful name.
Actually, there's another name for it, but that's just the scientific name for it. It's about 3/4 the size of Pluto. And then we found a few more. There's the one that's 2005 FY9. It's 3/4 the size. And then there's 2003 UB313, and that's actually larger than Pluto. And all these things are orbiting out there beyond the orbit of Neptune amongst Pluto. So Pluto is just one of the largest, not the largest, but just one of the largest of these very distant objects out there. And so what we have now is another asteroid belt, is what I think we have out this far from the sun. So we've not really been able to show the Oort cloud exists. We've not been able to show the Kuiper belt exists. In fact, there's evidence to show that what they think is the Kuiper belt really isn't. So I don't think there really is a source for long and short period comets, because I think the solar system is very young and God made them when He made the rest of the solar system.
So that's fascinating, because without the belt and without the cloud, there's really no source for comets not being made but coming into our awareness.
That's right. If the solar system is billions of years old.
It's billions of years old, which is a great hint towards a young Earth.
And it's one of those things I think that we recent creationists can take a lot of solace in, that we have some evidence here of a recent origin.
So where does this research lead us? Is there ever going to be a consensus on this?
Oh, I don't think so, because the evolutionists are going to have a real change of heart there, change of attitude. Because once you realize there is a creator, then it's incumbent upon you to be responsible and accountable to that creator. I'm talking about now sin, and I'm talking about repentance of those sins.
So when the evidence gets too close to acknowledging there's a God to whom we have to be accountable, we have to come up with another story, another way of explaining it, because that's where we don't want to go. We cannot allow there to be the idea of a God.
That's it.
Yeah. I'm so glad to know that on this end of a telescope, God has guys like you that believe in God and are using the heavens to declare His glory and not to create skepticism in the hearts and minds of our young people. Thank you for the work you're doing.
You're welcome.
Every time we look at the evidence of science, we begin to see more and more evidence of the veracity of God and the truth of God. And you know, I just hope that our show today on comets will help you to see that maybe this world is a little younger than perhaps some of you thought it was. And if you are a young Earth believer, perhaps this is going to reinforce in your heart and mind the truth of God having made it all not that long ago. Above all, I want you to remember this, my friend. It was God's view that He created you, and that should always be your worldview too. Hope to see you again soon on Origins. Until then, God be with you, my friend.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 901 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 901, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.